Okay, so this is kind of the opposite of our expansion of logarithms. This is more of a collection of logarithms where I take the expanded version and I go the other way. And I try to create a single log out of a sum or difference of logarithms with the same base. And so I've got two different natural log terms here, and I want to see if I can't collect these into a single term. And I'm going to be using those same three rules, right? And so I've kind of labeled those as one. That was going to give me and I'm going to just call it natural log because the base is arbitrary. So a natural log is shorter to write. Natural log of m times n is the same thing as the natural log of m plus the natural log of n. 2, we labeled that as the natural log of m raised to the p, or log base a, any log, is the same thing as p times log of the base of the exponential inside the argument. And then I've got my third rule, and I said that was that the log of one thing divided by another is the difference of the two, right? And so I've got I got arbitrary base log of m minus arbitrary base log of n. Okay. And so in this case, I want to use those three to put these back together rather than take them apart. And so I'm going to start out by using rule 2 there on both these to take the coefficient from the front and bring it into the parentheses, into the argument of the function. And so in both of these cases, those 2's are going to come into the parentheses. And I'm going to have natural log of x squared minus the natural log of the square root of x squared. Okay, well, square root of x squared is going to be x, right? And so we'll go ahead and rewrite that. Natural log of x squared minus natural log of x. Now, that really kind of screams at me rule 3 here, because I have one minus another with the same base. And so I want to use rule 3, not 2. I don't know why I said 3 in row 2. Rule 3 there. And I want to create a ratio with this. And so that's going to become the natural log of x squared divided by x. Well, definitely seems possible to simplify, because x squared over x is just going to be the natural log of x. And so these two at the beginning were actually a really complicated way of just writing natural log of x. Okay, let's take a look at another one of these. Let's look at something like, this is 45 from the homework. This is natural log, so kind of new problem. Natural log of x squared minus 4 minus natural log of x minus 2. Oh, it's x plus 2. Didn't make a huge difference except for, actually solving the right problem. Okay, well, if I go back to my rules here, what do I want to do? Well, I've got two logs of the same base with subtraction between them. That looks an awful lot like rule 3 here, because that's two logs with the same base with subtraction between them. So I can combine those. So I can use rule 3 there to combine these two into a single log. What's that going to look like? That's going to look like the natural log of x squared minus 4 divided by x plus 2. And you turn that in, you're all happy, and you get a 3.5 out of 5, or 4 out of 5, as far as the problem's grade goes. And the reason is we were supposed to notice that this is an a squared minus b squared pattern in our numerator. And that difference of squares always factors to a plus b times a minus b. And so this is actually the natural log of x plus plus 2 times x minus 2 divided by x plus 2. And so the x plus 2's are going to cancel. Removable discontinuity, anybody? And now I'm going to have the natural log of x minus 2. And I really should write where x does not equal negative 2, because that was a value here. But I already know that because this is a natural log, the domain of a natural log starts at 0 and goes to infinity. And so I already know that x must be 2 or greater. And so I really don't have to write that. What I really need to write is that x must be greater than 2, and strictly greater than 2, because otherwise I am out of the domain of natural log. Right? Because if you think about it, natural log's graph, it looks like this. And so x values cannot be negative as far as what goes into the argument there. And so for any x that's less than a negative 2, I get a negative value there. Okay. I think that's a pretty good example. Let's take a look at one more. Let's make it just one more, incrementally more complicated example. And so let's take a look at log of x squared minus 5x minus 14 minus log of x squared minus 4. Okay, well, if I go back up to my rules here, let's go ahead and just copy those and bring them back down so that we can look at them at the same time. If I bring those down here with me and maybe shrink them a little bit and change colors so they don't interfere with what we're going to do next. What am I going to notice? If I want to combine these two logs together, I've got two logarithms of the same base separated by subtraction. That's definitely a 3, right? Because I got two logarithms of the same base separated by subtraction. They can be combined into one divided by the other in the argument. And so I definitely want to use 3 here. And so that's going to be log of, now I have x squared minus 5x minus 14 divided by x squared minus 4. And this is why I say that it's a ridiculous thing to talk about any test as though we're not comprehensive. Because to be able to solve this problem, to be able to simplify this problem, we have to be able to do factoring like we did much, much earlier in the semester. Just like before, we're supposed to notice that that's an a squared minus b squared. Difference of squares. This is a plus b times a minus b. And so that's going to factor into an x plus 2 and an x minus 2. So we might as well write down here log. It's a common log. And then my denominator will be x plus 2 times x minus 2. But the numerator, it's a trinomial with a 1 in front of the x squared. That means if it factors, it'll factor into two binomials that start with x, because the first of FOIL will be x times x, which will give me that x squared. Now, if this factors, I'm looking for numbers that multiply to negative 14 and sum to negative 5. And so I'm looking for factors. So I want factors of negative 14 that sum to negative 5. Well, if I break 14 up into its factors, negative 14 up into its factors, the first ones that come to mind, well, you've got 1 and 14, right? So you could have negative 1 and 14. But that's not going to do the trick, right? Because they give me a 13 for a difference between the two. And that doesn't work, so oops. My knuckle, literally I'm a knuckle dragger. My knuckle triggered a gesture. Okay, and so now that negative 14, rather than 1 and 14, well, the next thing I'm going to do is 2 and 7. And negative 2 is not going to do it, but a positive 2 and a negative 7 will multiply out to be negative 14, and negative 2, or positive 2 plus a negative 7 will give me a negative 5. And so that's exactly what I'm looking for, is a plus 2 and a minus 7 there. And then we notice, after we've got that put together, that I have x plus 2 divided by x plus 2, which is 1. And so I end up with log of x minus 7, x minus 7 divided by x minus 2. All right. I hope that helps us with working with our logarithms.